So 1.416 you said there. Yeah.
I don't think I did this one here, but if we, like, for example, wrote negative 1.25 instead of negative 5/4, we still get the point.
Yeah. But if an answer is a fraction, I'm going to try my best to get you to keep things in fraction. It's given to you as a decimal, we can leave it as a decimal. But throughout the year, we will work on fractions, keeping things as fractions, doing fractions in your head without relying on the calculator, that kind of thing. No, okay, so number 16 says the area of a rhombus is 1/2 and then D1, D2. And you're asked to solve for D1. So we want to get the distance of one of those legs to be, or solve for one of those legs. So what do you think you could do first? Chris? Yeah, why would you want to do that? Yeah, so let's get rid of the 1/2. Instead of dividing by a fraction, you're multiplying by the reciprocal. So we're not going to divide by the 1/2. Another way of getting rid of that 1/2 is to multiply by the reciprocal, which would be 2. Because 1/2 times 2 is equal to 1. So let's get rid of the 1/2 by multiplying this one by 2, because that cancels out my 1/2. But I also need to do the same thing on the other side, multiplying it by 2. So anytime there's a fraction, try to think you want to use the reciprocal instead of dividing it. All right, so we still need to get D1 by itself. Chris, what else would you do? Yeah, so we're going to divide out D2. So D1 would be equal to 2 times the area divided by that second distance of the other side. Questions? Does anybody remember what those D's represent in a rhombus? It's the distance of something, but the distance of what? My rhombus isn't looking very good here. Should I grab my sheet? What does that D1, D2 represent, Chris? Yeah, that's the distance of the diagonal. So the one diagonal, the second diagonal. Those distances are different. One's going to be longer than the other. Just from geometry. We won't use a lot of geometry. Every once in a while they'll sprinkle in, but it'll, like, the formula would be given to you. Nice job, Chris. You're on your game for a Monday morning. Any other questions? That's a surprise. So I'm going to take a peek at that to see how you did. Don't panic if you get it back with a lot of comments on it, the first couple of homework assignments. I need you to kind of think about the process of doing homework. So if you see a lot of comments on it, it's okay. It's a learning curve. It'll probably take you a couple of weeks. But if you can pass that forward, make sure your name is on it. I don't have anybody's handwriting memorized, so make sure your name is on there so I know who it belongs to. So today we're going to talk about absolute value and inequalities. And it's the last section of that little chapter 2 packet. So if you could take that out, turn to section 1.7, and there's an equation to solve and 2 inequalities to solve. As you're doing that, I'm going to pass out some wonderful books to you. Because on Wednesday, you're going to start to use them. I will tell you that I'll have a class set in here, so you don't need to bring it to class. And then I just gave Victoria a sheet where you can put your name and book number in it. It's not Victoria, Veronica.
Yeah.
Veronica, not Victoria. Sorry. So the sheet is for you to place your book number and your name. Again, you don't have to bring it to class. Feel free to take it home. If we're permitted to get the online version, I'll give you information about that when I find out about that. So if you look at the first equation, just a tiny little equation here, subtract the 52, divide by 3. Or subtract the 15, divide by 3. And Michael, what do you get for x? Good. When it's an inequality, pretty much solve it exactly the same way, except in the directions above. It says, remember when multiplying or dividing by a negative in an inequality, you have to make sure you flip the symbol. It's only when you're multiplying or dividing by a negative. So in this case, when you take the 8 to the other side, you're adding it, dividing by a positive 5, x should be less than or equal to 3. And then number 3, this is called a compound inequality, being there's 2 that we would look at graphing on the number line. It's divided or separated by the word or. Sometimes the compound inequality is actually grouped together with 2 inequality symbols and kind of like an equation stuck in the middle. I think we'll look at one of those on the other side. So 2x plus 1 is less than negative 3. Solve that inequality separate. The other inequality, 2x plus 1 is greater than 5. You can solve that one separate as well. So you're kind of just solving both of them. So x is less than negative 2. Or x is greater than positive 2.
What's the sign flip in number 2?
Are you dividing by a negative number?
Oh, by negative.
Right. So the only time the sign flips is when you're dividing or multiplying. Some people forget about the multiplying part. Dividing or multiplying by just a negative number. Positive numbers are okay. It's just a negative number. So looking at number 3, if you were to graph this on a number line, because a lot of times inequalities are kind of answered with a pictorial answer. Place a 0 in the middle, couple of numbers on the bottom. How would you graph x is less than negative 2? Peter?
Wouldn't it be like open circle?
Yeah.
The negative 2 and then arrow go to the left.
Right. So when it's less than or greater than, it's an open circle. The closed circle happens when it's equal to, because that number actually exists. In this case, you're getting really close to negative 2, but it doesn't contain the number negative 2. And then the tip of the inequality symbol points to the way you're shading. So we want the solutions when x is less than negative 2, so you would shade in that direction. Some people prefer to graph above the number line, which is fine. You're going to do exactly the same thing for the other part. So both of them go in the same number line. So the second one says x is greater than 2. So again, you're going to 2. It's just greater than. So we place an open circle at 2. And then greater than means bigger than 2, which are all the numbers to the right. So if you prefer your numbers to be graphed above and your lines to be graphed above so they don't run in with the number line, that's fine. And it just depends on who you had as a teacher and how you were taught. Questions? So we're going to look at absolute value today. What would a definition of absolute value be? So what does absolute value mean?
The distance number is away from zero.
So absolute value is the distance a number is from 0 from the number line. Jack, what's special about absolute value? So if I'm at -5 or +5, that distance is going to always be to get to 0. They're going to be the same, right? Distance is always positive. So the distance from -5 is a +5. The distance from +5 to get to 0 is also +5. So absolute value is always positive. We're going to write a little definition here that's more algebraic. Sometimes we like to see the algebra definition. So absolute value of x, any number, can be kind of thought of in 3 separate cases. So the first case would be x if x is greater than 0. My x could be 0 if x is equal to 0. And the last case we have to account for would be the negative. I could have a negative x in there as well. I could have a -5, a -10, a -20. And that happens if x is less than 0. That's the algebraic definition. So I would have x, the absolute value could be a positive number inside, it could be a 0 inside, it could be a negative number inside. That's kind of what that is saying. You're going to have a positive number if it's greater than 0, you could have a negative number if your number was less than 0. But absolute value makes any number positive because it's distance. You're measuring distance, you're getting to the middle. So we're going to look at solving absolute value equations. And there are a couple of steps that we can use to solve an absolute value equation. It says when the c is greater than 0. So if I look at this equation, we have a couple letters in here. ax plus b with the absolute value bars. And then it says is equal to c. So the a, b, and c are just constants. They're numbers. They can be anything. So just 3 different numbers. They could all be the same. But we use different letters to represent those values could exist. So the first step is going to be to actually separate this into 2 equations. Our goal is to actually get rid of the bars so that we can solve for them. So the first equation is going to say ax plus b equals c. It's going to be exactly the same equation, but we're going to get rid of the absolute value bars. The second equation is still going to say ax plus b. Josh, Nick, what do you think it's going to be equal to? A negative c. And that kind of is based off of the definition. So because the center of the graph, I can have a negative number but still have the same distance. I could have a positive number but still have the same distance. when we actually solve for absolute value, we have to take into account that you can have both the negative and the positive. So that's why we have these two separate equations. So the positive side of my x versus the negative side of the x. But you're going to have the same distance to get into the middle of the graph. So the second step would be to actually solve. You're solving both of them though. So we could have two answers. Again, because I can have the same distance on either side of the middle of x. And then the last one would be to check your solutions. Sometimes we can do a little mental check, other times we might have to show a little bit of work. So the key thing to remember is that you can have a number on the left and the right that has the same distance to get from the center, which is why we're going to have two equations to solve. So I believe there's an equation underneath there. Pretty straightforward one. And I think you also have a number line drawn. Solve x minus 3, absolute value of x minus 5, equals 3, and then graph the solution on the number line. So x minus 5 equals 3, pretty straightforward. Except you have to remember that there are really two equations here. Because I can have that same distance on the left and the right to get into the center. So, Nick, one answer would be?
X equals 8.
And the second answer would be? And if you do a quick mental check, 8 minus 5 is 3. 2 minus 5, taking the absolute value of it. So if I plug in a 2 here, I get negative 3, but the absolute value of negative 3 is positive 3. Questions? So then I want you to graph it on the number line. So we're plotting these two values of 8 and 2. Michael, what number is in between 8 and 2? What's directly in the middle of 8 and 2? Or 2 and 8? 5. Here's the middle. Where does that 5 in the equation? So notice the 5 in the equation. It says x minus 5. This 5 in the equation represents the middle of the two numbers. The distance from 5 to 8 is 3. The distance from 5 to 2 is 3. That's what the equal sign means. So my middle number is 5. The distance to go up 3 or down 3 takes me to 2 or 8. So 3 should be the distance from the center number to get up to our two solutions. So that's what a graph of an absolute value answer would look like. Questions? So if you want to flip your page over, there's a second absolute value, a little more interesting. See if you can solve this absolute value. So cool, the two answers that you got were?
X equals 11 and x equals -7.
And again, doing a quick mental check. 5 times 11 is 55, minus 10 is 45. The other one, 5 times negative 7 is negative 35, minus 10 gives us negative 45. But once you take the absolute value, you go back to the positive 35. Any questions? So there is a vocab term underneath, and it's called an extraneous solution. It says that the definition could be found found on page 52 of your book. But if you look at the word extraneous, what do you think that means? Something is extraneous. What word is embedded in the word extraneous? Ian. Extra. So Nina, what do you think an extraneous solution is?
Sounds like extra solution.
Yeah, it's an extra solution. So sometimes we have extraneous solutions or an extra answer. That does not work. When substituted into the original problem. We're going to run into these various times throughout the year. So literally, it's an extra answer. Sometimes we're going to have 2 answers, sometimes 3. When we get to chapter 5, we actually might have 5 or 6 answers. But we have these extraneous solutions that sometimes occur because we're manipulating the original problem. And those extraneous solutions might not work every time. So I have this extra answer that I check it back in and it doesn't satisfy my original equation. So if you look at example 3, this one now has a variable on the left and a variable on the right. I want you to solve it, and then it says check your answers. So just like we solved the other 2, we're going to still separate them into the positive 4x and the negative 4x. I still need to account for the distance from 0. Could be a negative number, but a positive distance, a positive number, but that same positive distance to get to the middle. So Leah, the 2x values you got were? I agree with the 6. Instead of 2, it should be a negative 2. So those are the 2 answers. The next thing it says is to actually check those answers. And when you check them into the original problem. So I need to check it back into the original problem. So just to kind of show you, we have 2 times 6 plus 12. But because there's an x on the other side, I need to also plug in that other value. So 2 times 6 is 12, plus another 12 gives us 24. And 4 times 6 is 24. Leah, does the absolute value of 24 equal 24? Yeah, so I'm going to put a little check mark here. It works. I checked it. The other one, doing the same thing, 2 times negative 2 plus 12, and 4 times negative 2. Again, go back to the original problem to check it. Not the 2 equations you made, but the original problem that you were given. So over here, we have negative 4 plus 12, so that makes 8. But on the other side, we have 4 times negative 2, and that's a negative 8. Does the absolute value of 8 equal negative 8? No, Josh, sorry. It does not. So, Josh, what do you think that means about x equals negative 2? Right, it's an extraneous solution. So I usually put a little x next to it. You could put an x through the whole thing. But you need to go back to your answer and place an x through it as well. It's extraneous. So it's an extra answer that we found, but it doesn't work when you check it back into the problem. So we found it in the process, but it doesn't work when we go back to check it. So there's only one answer here, and that's x equals 6. So instead of there being 2 answers, there just happens to be 1. Questions? So those are absolute value equations. Underneath, we have an absolute value inequality, and it wants you to then sketch your answer on the number line. So Jack, how do you think you would solve an absolute value inequality? Okay, same way as an equation. So that would be my first one. What would the second one look like then?
Same thing, so with the greater than, or less than,
So he said it should be less than instead of greater than. What else is going to be with this? A negative 13. So because we're dealing with inequalities, if you're placing a negative in there, you're really kind of like multiplying by a negative 1. When you multiply by a negative number, you need to flip the inequality sign. So the first equation stays the same, or inequality stays the same. The second one, we're making it a negative 13, and then you're also flipping the sign. So see if you can solve that inequality, two inequalities, and then graph your picture on the number line. So where's the answer? So again, you're making the second one negative, you're flipping the sign because really we're multiplying by a negative 1 there. So Stephen, one answer would be x is greater than,
2,
and the second answer, x is less than,
negative 4.5.
negative 4.5, negative 9/5, or 9/2. Again, I'm going to try and get you to keep that answer as a fraction. Not even a mixed number, as a complex fraction. So negative 4.5, negative 9/2, x would be less than, and then x is greater than 2. So again, greater than is an open circle. Bigger than 2 means we want the numbers that are larger than it, which goes to the right. Less than is also an open circle, and we're at negative 4.5, which is in between here. And then we're shading in the other direction. Questions? So I believe there are 4 problems on the last page which say, like, practice. Yeah. First 2 are inequalities, the second 2 are equations. So solve the inequality. And then the second group, solve the equation. Bless you. Anybody have the first 2 answers for A? Peter, what do you have?
X is less than 4.
positive 4.
Yeah.
And then the second one, we have 2/3 z greater than 18. What do you do with the 2/3?
Find 2/3 of the other side.
And how would you take it to the other side?
Would you multiply it?
By
Oh, wait.
3, and I could also in the same step divide it by 2. So if I want to get rid of this 2/3, if I multiply it by its reciprocal, by multiplying by 3, that cancels those out. Dividing by 2 cancels those out. So anytime you have a fraction, if you multiply by the reciprocal, it cancels the entire fraction out. So then I'm left with 18 times 3 halves. Peter, that is 27. Doing the exact same thing on the other side, we have 2/3 z is less than -6. So by multiplying by 3 halves, multiplying by the reciprocal to solve the fraction, that cancels both of them out. And that answer is, listen, say again?
-9.
-9, yeah. Any questions with the inequalities? Yeah, see
Yeah, we just divide by the fraction that's already there.
No.
Okay.
Actually, correct, because you plugged it in your calculator. And you made sure to put parentheses around it. But the actual process the calculator is doing, it's already embedded in that, is it's multiplying by the reciprocal. So that's what the calculator is really doing when you plug it in. So it's doing that like multiplication with the reciprocal for you. Other questions? So the last two equations, don't forget to check your answer into these two equations. So for the first equation, by splitting them up, you end up getting x to be 5, and then x to be -1. And when you plug them back in, we get the absolute value of 15, which is definitely 15. The first one is good. When you check the second one, we have 2 times -1 plus 5. We end up getting the absolute value of 3, which does not equal -3. So here's my little check scratch work on the side. This one doesn't work. So if it doesn't work, make sure you're crossing off that answer. You get an extraneous solution, cross off the answer, or circle the one that's correct. You need to kind of identify what your actual answer is. How do you think you'd separate the second equation with letter B? And why would you make both of them negative? Nice job. So when you look at the second equation, if there are multiple terms on the second side, a term is a piece of the equation separated by an addition or a subtraction problem. So if there are multiple terms, then you need to make sure that you're making all of those terms negative. So not only the first term, but also the numerical value as well. And then when you check it, make sure you're checking it into both sides of the equation. And the first one does work because 19 is equal to 19. So So check both sides of the equation as well. The second one, we get 6x is equal to negative 8. So x would be negative 4/3. Evil fraction that I have to check. So again, check it into the original equation. So 4 times negative 4/3 minus 1. On the other side, 2 times negative 4/3, and then plus 9. If you want to use your calculator for a little bit of extra help here, you can. Anybody know what number you get in the absolute value? Negative 19/3. And on the other side, Peter, you got negative or positive? Josh? Yeah, it is a positive 19/3 on the other side, and that's because this 9 is a positive 9. Put it in your calculator, check. So does the absolute value of negative 19/3 equal positive 19/3? It does. So both of them check out in this case. So we have 2 answers, whereas the other one, the second value, did not work. Any questions? Again, feel free to use your calculator to check with those fractions. If you're doing it mentally, awesome. Gotta get a common denominator of a 3 there. So for your homework tonight, I'd like you to do the odds of this worksheet. Either do the problems on the back, because the back is actually blank, or on a separate piece of paper because you like using line paper. Oh, you just get it? So odds at the top, right, that you're doing the odds for these problems. The answers are still on that original worksheet that you got last Wednesday in class. Please check your answers. So 1 to 27 odd, separate piece of paper or on the back. Did anybody not get the book sheet? So tomorrow we'll review for a 30-point quiz on Wednesday. Have a fantastic day.